ZFS, developed by Sun Microsystems, released in 2005, combining the file system with the volume manager. And Jeff Bonwick was the lead engineer. He created it with Matt Aarons. And they had seen lots of problems in UFS and other file systems and wanted to really rethink it. And so folding in the volume manager and making pooled storage. I believe one of the things Bonwick wanted to do was to have file systems as easy to use as main memory. Like why are we doing these disk partitions? And then we do volumes on the disk partitions, and then we do file systems on the volumes on the disk partitions. Shouldn't disk storage be like main memory, where it's just contiguous, it's just memory? And then if I want to divide it, I can arbitrarily do that in a flexible manner afterwards. And so that's what ZFS does. All my storage devices go into a pool. And then I can just arbitrarily divide that up, put quotas on it, grow it, shrink it. Well, shrink the quotas, that is. So it is much more flexible and removes a bunch of steps for system marketing. When someone was marketing this, they actually counted how many system administration steps it took to create file systems on an earlier Solaris box with UFS and then with ZFS, and it was many fewer steps. ZFS also includes many enterprise level file system features that normally you wouldn't see in the standard OS that came with the standard file system that came with the OS. Normally you'd have to go to Veritas and purchase a license to an enterprise grade file system to use. And there were things like logging, copy and write, variable size blocks, dynamic striping, multiple prefetch streams, snapshots, clones, compression, scrubbing, large checksums. And they added things like hot spares, double parity RAID, gzip compression, a separate log device, L2ARC, and other things as well. So it's really got a ton of features. And Sun open sourced it as CDDL. So we don't think it's ever going to be part of the mainline Linux kernel tree, but it's certainly being used with Linux. And it's it's already standard in the Solaris family of operating systems. It's also being used in FreeBSD a lot. So I list the key performance features. There's a page and a half of these, and this is just summarizing it as short as possible. And a lot of these, actually all of these that I'm listing, all of these features are to do with performance. So performance is very important. And key ones, pooled storage means previously I had to divide my disks into volumes, and I had to allocate them to volumes and then put file system on the volumes. And I typically have a server with, maybe it had 12 disks, and I could only have a fraction of those disks for each different workload or application that was running. With ZFS, I put all the disks in a pool, and so the applications get to use all the disks all the time. And all those extra spindles online or flash drives online increases their throughput. Copy and write to group and write data sequentially is great. Logging for transaction groups. They batch writes for improved synchronous write throughput, asynchronous write throughput. ARC is, the ZFS ARC, what it does is it maintains information for a most recently used policy and a most frequently used policy, and then sees how each would have performed, and then dynamically switches memory between them based on tracking performance. And so it's designed to have a better hit rate than either alone. And so it will dynamically switch. Some of these are already mentioned. L2ARC is great L2ARC is great if you have a random read workload and you want to take it off rotational disks.